I'm Dave Ferguson, Dean of the College. It's my pleasure to see you all here and to let you know that we have an outstanding lineup coming this year. Next Monday will be a very intriguing presentation by Phil Bernstein from Yale on AI, which I know everybody's interested in. And then coming down the pike, we have a number of other talks and workshops that will all dovetail into a number of topics. For AIA credit for the faculty, that is available for this session today. And for the students, feedback is always welcome. So we really do try to tailor this to your interests and needs. And so feel free, there's a survey form. Christine, Ryan can direct you in that, towards that. And we'd love to hear what you think and have new ideas for upcoming lectures, including I think we may even have a couple of spots still for spring semester, but certainly for next year. So without further ado, I'm going to introduce the introducer of our speaker today, and that is Ellen Dane, who is an alum, but also an instructor in the Department of Architecture. Ellen.
All right, good afternoon. So Alvin Huang is the founder and principal of Synthesis Design and Architecture and an associate professor at the University of Southern California. He's an award-winning architect, designer, and educator who explores the intersections between technology and culture to produce innovative design work that challenges convention and expresses universal values. He's a vocal advocate for justice, equity, diversity, and inclusion in design culture. His work spans all scales, ranging from high-rise towers and mixed-use developments to temporary pavilions and bespoke furnishings. If you guys could give Alvin a warm cap welcome.
Thanks, Alan, and thank you all for having me here. It's a pleasure to be here. I was actually born in the Midwest, grew up in Minnesota and Illinois, and moved when I was 9 to Los Angeles, and then lived in London for a few years. So it's nice to be back in the Midwest and get a nice Midwest welcome. It's always nice to remember the hospitality that you get in this part of the country. I used to joke, or my father used to joke when we first moved to LA, like in LA, if you pull over and your car breaks down, the first car that comes up, or in the Midwest, if you break down your car and you pull over, the first car that passes by will pull over and help you. In LA, if you pull over and the car pulls over, you roll up your windows and lock the door. So it's nice to have that reciprocal side of this. So the talk today is called Form Follows Values, Creation, Contingency, and Culture. And it's stemming from a lot of the work that I do in my office, that is my own personal research and creative practice, but also a lot of reflection on the things that matter to me and how they are reflected in design, but also how what matters in design becomes an alibi for form. And when I mean alibi for form, I mean the fact that I came of age in the early 2000s, working in practices like Zaha Hadid Architects, Future Systems, and Amanda Levite Architects, pre-2008, in an era where I would say there was a lot of digital excess and a lot of opportunity to build whatever you wanted to build as long as a client could throw enough money at it. And then post-2008, we had to find ways to justify what we were trying to do in really, really different ways. And for me, that was beginning to identify the value propositions of form, and meaning that form has more to do with things that you value rather than the form itself. And one of those ways that I frame this is in terms of beginning to think about what we call the discipline, the profession, and the commons, and what I identify as the 3 lenses of architecture. And by lenses, I mean the way in which we view architecture. And I would say almost all of you in this room probably came to school because of the lens of the profession, right? You came to school because you wanted to learn how to be a professional architect, how to talk like a professional architect, how to speak to contractors, how to talk to clients, how to get a building permit. But one of the things that is really interesting to me is the fact that 85% of the built environment is not designed by architects, which means 85% of the environment, of the built environment, had to pass a pan check, had to get a building permit, had to be structurally sound, had to be weatherproof, had to be all these other things that the profession does, but they weren't done by architects. So are they architecture? The remaining 15%, also designed by architects, doesn't all call into that category of architecture. All of it falls into the category of the commons, meaning you, me, your mom, your father, all of the people we know occupy and live with the built environment and have to engage with it and have to read it and have to experience it. But only a select few, meaning us in this room and those of us in the discipline, have the ability to speak with it as a discipline, meaning have a conversation about it as it relates to other work that happens in architecture, to talk about it in relation to architecture, and to use those opportunities to leverage the profession to affect the commons. And I think that's where I'm interested in, and really thinking about how architecture is the interrogation, expression, and materialization of our value systems into the built environment, right? And so those value systems are not just about what we think about as, let's say, kind of values from a capital sense of what we find valuable, but they're also not necessarily exclusively what we think of from a moral or ethical sense in terms of what we find valuable as an individual. There are also things that we find valuable as intellectuals. And I think some of the things that I'm really motivated by are embodied in these three quotes right here. One by Florian Eiderberg of So Ill or Soil, where he talks about the value of ideas and the ability of ideas to affect change because ideas provide alternatives. They provide an opportunity for us to rethink about what could be. Benjamin Bratton talks about the possibilities embedded in culture, how about technology and culture are interwoven. And I think there's never been a time in society that it's more clear than right now where technology and culture are synonymous. And the third is probably my favorite quote, a quote from Cedric Price. Technology is the answer, but what was the question? This is coming from a talk of his in 1966 when he's talking about technology at a very, very different time. But I think it's still a very valid question where now technology and culture are so synonymous that the answers are technology, but what really matters is the questions we ask of it. And technological questions produce technological answers. But cultural, social, intellectual questions can produce social, cultural, intellectual answers that technology can provide. So one of the values I'm really interested in exploring is the value of craft in a post-digital era. I will be open and honest about this. I was setting up this lecture with a series of chapter pages that go in between all of the projects, and I got about halfway through before I got called up here. So these chapter pages only show up in a handful of the projects, and then they go away. But I'll talk about them in the rest. So the value of craft in the post-digital era, and I think what I really want to emphasize here is post-digital era. And what I mean by post-digital is not that we're not digital anymore. It's that we don't have to talk about digital anymore, right? We used to talk about email as digital. We used to talk about AutoCAD as digital. Now it just is, right? Like nobody cares that it was done by a computer. You just wrote the email, that's it. And nobody cares that there is a 3D printer in the future. It just is, right? But there's still a craft to thinking about how we work with these things. And one of the things that I'm really interested in is how you design a 3D print rather than 3D print a design. And what that means is 3D print a design. You design it without the 3D printer. And then when you finish designing, you go to the 3D printer and you hit print and you find out what it can't do. Right? If you design with the 3D printer, you're actually leveraging it and trying to articulate and trying to find what the opportunities are provided by that mechanism for you to design by its constraints. And in this case, it's a rocking chair that's looking at the process of durotaxis, which is the redistribution of cells to align with principal stress within the distribution of the form. And because of that, it produces a dense three-dimensional mesh, which has different densities where the form and the force coalesce, and you get read where the stresses actually move through. All 3D printed in this case a Connex 500, produced by Stratasys, which is a manufacturer of 3D printing that can do what's called multi-material gradient printing. So in this case, it has, compared to like the 3D printers that we probably have up here, where you have one head, one nozzle, probably prints at about 1 millimeter, 2 millimeters per layer. This has 2 heads. Each head has 96 nozzle. Each nozzle prints at 16 microns. And what that means is I can have one head which is distributing an opaque, blue, rigid material, and another head which is producing a white, translucent, soft material. That's as far as you can go with Stratasys because it's all proprietary. They won't tell you what anything is made of. They just describe it in like blue, opaque, soft, white, translucent, hard. But you can do these different gradients between them and do a matrix between them and produce these gradients, which allows you to produce things like this, which actually dissolves from the soft areas where it touches your head to the rigid areas where it touches the floor. But one of the things we found with this was that when we asked to produce this, we produced it for Stratasys for an exhibition, and we asked if we could have one ourselves, and we would just pay for the printing cost and the material cost. They said, sure, that'll be $18,000. And we said, it's okay, we'll take pictures. We talked to them about it, and we went back to this and realized the big cost and the big waste is actually in that top left right there, which is when you're printing it, you're pretty much printing it as a solid mass, then spending all of this post-production time to dip it into a bath to remove all of the support material, and then paying a technician to clean all of that stuff out. So what we started doing was looking at how we could work with our MakerBot in our own office and look at a process known as corbelling. So corbelling is a process in medieval bricklaying where you incrementally cantilever layers of brick to produce a cantilever. And it reaches a certain critical mass where it starts to fall, but you can intercept it with another angle. And so we began testing different layers and different angles of repose on our own 3D printer. And so this was a long time ago before a lot of things had happened. And testing it until it would start to fall and where we had to intercept it. And we produced these growth algorithms which would grow from a flat surface towards an outer spherical form. And we were able to produce this lamp in our own office, which is down over my dining room table, for about $16 in filament with zero waste. So it grows from an inner isodecahedron, which is that inner form here, which allows it to grow from a flat surface towards an outer sphere and then welded together. In this case, by an intern. So, which became another project called the Kagome vase. And this vase is a project which we recently exhibited at San Jose State University at an exhibition called G-Code is My Love Language. G-Code is the code that the printer is sent by the computer that tells it its instructions on how to print. And in this case, we're beginning to look at how we can print something, or a vase, which has an embedded internal vessel, right? So it's a three-dimensional mesh, which has these apertures that move in, and then in the red, you see this internal vessel, which is printed solid. So you're basically printing an object inside of an object. And beginning to look at different tessellation patterns. This was sponsored by Carbon 3D, working with Carbon 3D's latticing. Built now all the stuff we were doing totally algorithmically, written exclusively in Grasshopper using Python and RhinoScript. Now is a series of sliders in Carbon 3D's internal proprietary software. And so we're working with their software and testing these things very iteratively, looking at multi-zonal lattice variations and producing variations. And in this case, they use a process called digital light synthesis, where it's actually printed upside down. And so what you're seeing here is the piece being pulled out of the liquid, and there's a laser that is producing a light print at each level. And as it's coming out, it comes out solid. Zero waste, and getting to like super fine detail, and almost, I think, connecting to a more disciplinary conversation about line weights and line types and architectural representation, but in three-dimensional form. Where, I don't know if you guys are familiar with Dwayne Euler's drawings from Euler Wu, but his hand drawings are incredible, and they look a lot like this, right? Like, which is this kind of interwoven mesh of really, really thin lines that through their density starts to become opaque at times and at times even solid. And so this is the vase at the exhibition in San Jose State. Another project where we began looking at a different set of values was about the value of data. And data, in this case, as visual information, as it relates towards the guys from HBO. But basically, this is a showroom for IBM Watson. This is IBM Watson's headquarters in San Francisco. where they are using IBM Watson, which is their not artificial intelligence, but machine learning, cognitive computing division. And it's a showroom that is used to how they can leverage these technologies for online sales for the tech community. And so what we started doing was working with them and thinking about how we could use Watson itself. We did a deep dive on 3 years of analytical data of online sales at IBM and looked at how that data could be produced as an algorithmic heat map. That heat map could drive a kind of series of patterns, in this case, an overlap between a Voronoi pattern on the outside and a Voronoi pattern on the inside, which takes that quantitative data, maps it across time, helps you identify peaks, valleys, hits, lows, things like that, and how they relate towards different times of the year, different days of the year, and maps it out as a map all the way around. And then not only produces something that is stunning visually, but because it has this overlap between a cold-formed outer steel, cold-formed stainless steel perimeter with an inner laser-cut aluminum surface, produces this moire effect. When you walk around it, it feels like this pattern is coming to life. And the pattern is actually a reflection of real data. IBM has since developed an app where when they're doing the online sales, they can actually hold the app up through their device and actually get the real-time data back by reading the physical pattern, which is pretty cool. But what it does is it actually turns the data itself into something that is narrative and actually something that becomes value for them in terms of selling, but also a sort of physical, visual thing. And I think that's one of the things that I feel is most important for us as designers, is how we can give physical form that has desirability and cachet to things that motivate people to desire them in support of things like sustainability or things of that nature, spatial justice. I think these are all issues where we are motivated by certain things, but without physical form and without being able to show our value as designers, not as programmers, and when I say programming, I mean more in the sense of not computational programming, but in the program, beginning to think about how what we do as designers becomes an opportunity for us to really bring value to things. And in this case, it's a Pavilion for the Volvo V60, which is a plug-in hybrid electric car. It's produced essentially as an accessory to the car. So this is a flat pack Pavilion, flat packs, and fits inside of the trunk of the car, inspired by these two images here. It's all produced with this process known as dynamic mesh relaxation, where we're taking the principles of springs and spring systems in rhino, grasshopper, and caramba, and testing them the same way you would with minimal surfaces. Taking that and looking at CNC pipe bent perimeters, in this case swaged aluminum pipe profiles, all rationalized into exactly 5 repeating arcs, and producing a solar incidence analysis that actually tells us where to place the solar panels of greatest incidence that has a relationship towards this pavilion being situated in Rome, because it was commissioned by Volvo Italia, rotated at 360 degrees over 365 days of the year to produce this heat map, which then helps us identify where the areas of greatest solar incidence are, and then expressing those things as variable sized panels, tailoring it like a suit, and then putting it together in this process, and ultimately resulting in this. The entire pavilion flat packs and fits inside the trunk of the car and wrecks in 45 minutes, charges the car in about 8 hours. The biggest thing that affects the slowness of its charge is the sun, right? So like you're not guaranteed a kind of constant source, and the problem with the solar panels is the entire array is charging at the lowest or weakest link. So whatever the weakest link is gathering, the entire array is charging at that rate. So this is one that I didn't get a chance to put in a chapter for, but this is a project where we're taking these same ideas and applying them towards a Pediatric Neurology office in Orange County in Southern California. For those aren't familiar, pediatric neurology is a field that they deal with children that have cognitive disorders. Children that have cognitive disorders, we did a lot of research, and they're stimulated by three particular things. That's color, geometry, and texture. And so what we wanted to do was embed this pediatric neurology with those three things so that the entire space actually becomes a sort of sense of stimulus to them, and a place that they actually think of less like a doctor's office and almost more like a playscape or a playground. There are 4 existing windows in the office, and we started looking at what we call occupiable poche by thickening the walls and then carving into them. These are some early studies. What we ended up arriving at was this, which is a sort of origami-inspired series of folded surfaces that have been contoured and covered with acoustic felt and CNC milled. We also did something unique in terms of taking the exam rooms, and instead of having them on the perimeter and then having a corridor up the middle, we placed the exam rooms in the center and flanked it with what you see here in the cyan is a back of house that wraps in an L shape, and in the pink, a front of house which wraps in an L shape, which allows the front of house to be where the clients and the children sit. The back of house is where the doctors and the staff sit, and they're able to move freely between room to room without being flagged down. And the clients can move directly into each of the color-coded spaces. We then have a gradient distribution of density, which is color-coded and CNC milled at varying depths. Piece coded here into the panel assembly, and then here you see the assembled final piece. All of the form that's embedded into that desk, which is a CNC milled and thermal-formed Korean desk, reception desk, is all requirement of a series of ADA requirements. So that knee kick, that clearance there, the sculptural move is actually just an ADA clearance. The move down is also about ADA clearance. All of these pieces here are then pre-fabricated offsite, brought here and installed. Behind the feature wall is actually a CT scan of the human brain, which is CNC milled into the wall. And then the series of color-coded doors and the acoustic felt. This has been one of the best feedbacks I've ever got from a client, in that she actually now has a new problem, which is the kids don't like to leave. So basically after their visits now, the kids are climbing, and you know, we didn't intend it, but basically those shelves back there become ladders, and they like to use it like a playground. This is a project which we're currently working on now in West Hollywood. We're not responsible for the entire building. You see that highlighted in pink is our site. And what we're doing there is a sort of coffee shop kiosk pavilion, which is not open 24 hours, but wants to be visible and operable 24 hours. And so what we mean by that is thinking of this almost like a Jewelbox. And we actually nicknamed the project the Jewelbox. And so this particular location sits in West Hollywood, in a very prominent site. This is Melrose Avenue, which runs across here, La Cienega Boulevard here. And the site is right there, and highly, highly visible from multiple angles, and a lot of traffic. And one of the things we wanted to talk about here is the value of public art, and the value of a public landmark that could draw attention to a space, draw attention to the place, and become a kind of urban beacon. And so we take this site of the existing condition. We're going to remove that tree, but because we're removing the tree, we're going to replace it with a green roof. We're going to look at the different flows of traffic, and then think about how we take that, which is a pentagon, which we came up with, which basically has one elevation facing the street and then divides it towards the other sides. But then at the top, we're looking at rotating it so there's an opposing pentagon at the top, and then connecting those two with a triangular set of surfaces, and then replacing that tree with a sort of internal folded origami canopy, which opens up with that green roof towards the sky above, produces this section which connects to the sky bridge above, so that when you're standing in that street level, you can see all the way through the building up to that canopy, and then from that sky bridge, and from that sky bridge, you can see through the building again. And then here you see the CNC milled Korean interior. So everything is going to be CNC milled Korean, which if you've ever worked with Korean, when you cut it thin, it becomes translucent. And so by milling it down to certain depths, certain parts of it become translucent. The intention here is that we will have no exposed lighting in the entire project. The entire project works like a glowing lantern. And sits here in West Hollywood in this prominent location as a kind of beacon for the site during the day where it's operable as a coffee shop, and then at night it starts to illuminate, and we're working with a lighting agency called We Are Chromatic, and looking at phase-changing LEDs that will basically pulse and change throughout the evenings and be programmed with different events. And eventually we'll be working with local artists to kind of curate the exhibition of how this gets used. This is a project which we did in Bangkok. It's a shopping center, but it's also an extension to an existing shopping center, which is 600,000 square meter or 6 million square foot shopping center, third largest mall in the world, called Central World. And right here, it's a really, really, really unique sort of value proposition, which we're talking about, which is the value of an alley. And if anybody's ever been to Bangkok, the alleys in Bangkok are called sois. And the sois are actually really, really unique because the most famous one is called Soy Cowboy, which is basically called Soy Cowboy because it's where all the GIs went to go see the ping pong shows and all the stuff, like that. But basically these alleys have become the kind of pedestrian thoroughfares and the areas that people go to because the streets are too polluted, they're too crowded, and they're too hot because they're not exposed to the sun. The alleys are small, they're intimate, they're quaint, and they're leafy, and they're green. And so what we wanted to do was really kind of invert this kind of urban condition here and create a series of internal arrangements. So rather than thinking of this in the traditional way of looking at it as a building that then gets divided by these connections and subtracted into atriums, was to think about it more like a series of courtyards, which are the separation between different buildings, right? And what we did is we set it up as a parametric model in IBM Watson, where we could adjust all of these, but then not only adjust them, work with the developer to connect it to a pro forma, where our adjustments were actually literally reflected real time in front of them as the true value of what they're getting back as lettable area. So our adjustments were something that we could sit there and work with them and fine tune and find a happy medium between what we wanted as a design versus what they wanted as a return on investment. Everything is picking up on the pulses of Planchet Road and its kind of series of highly, highly intense volumes of traffic. It's all clad in aluminum composite panels, which are perforated and backlit. We have a series of CNC milled timber soffits that are exposed, and a very indoor-outdoor condition. So it's not an enclosed mall, it's actually an outdoor mall, but one that has this kind of backlit condition, and this vision of it facing the street versus this vision of it facing the interior courtyard. And so these are open air courtyards. That's a retractable fabric roof that opens up and pulls back, that protects it from the rain and also softens the sun, and filters the sun. And here you see some of the detailing of the facade system. And then the interior timber soffits. This is a project which we did in Guangzhou, China. It's a competition that we won first place in, invited competition, 7 firms around the world. We got first place. It's the first time we entered a competition in China and got first place. Also, first time we find out that winning first place doesn't mean you win the project. It means you win the competition, and then the client and the government get to decide. There's a term in China called guanxi. I think some of the Chinese people might know it. It's maybe easier to describe. The official translation is about relationships. I think the real definition has more to do with nepotism and bribery. But in any case, we won, but didn't win. But it's a competition where this particular site sits in an area of China where the sea, the river, and the mountains intersect. And that intersection produces an overlap, which produces a series of cultural artifacts known as scholars' rocks, which many of you may have seen in Chinese gardens. But they're these beautiful, beautiful rock formations that are made by taking rocks, placing them in water, and letting the water run through them, and flipping them, and turning them, and rotating them. And they have a series of cultural values that are appropriated, that are assigned to them in terms of asymmetry, wrinkles, cavities, caves, all of these internal openings. And there are ways that Chinese scholars value these things. And we looked at those and thought of them as architectural values, and ways that we could say we wanted to have sky gardens and interior gardens and wrinkled, louver-protected skin, and ways of thinking about how we could embed sustainability into this, and looking at this louvered skin that was rotated at a 45-degree angle, which got a 75% reduction of the sun. The last project I'm going to show is a project that we started just before the pandemic, which you can kind of see in some of the imagery here, and got all the way through CDs, and then after the pandemic got it priced and the project got canceled. But it's a project that is very, very important to me. It would have been in Los Angeles in the Arts District. It would have been in this building. So this is in the Arts District. It's an existing two-story warehouse, which the plan was to keep the facade because it got designated as a historically significant facade, build a hotel and luxury retail condo through it, and then our site was that middle zipper there, which was an art gallery and event space. And so our proposal was this sort of internal building inside of a building that would peek out and puncture the building at two specific locations, facing two views, one to downtown Los Angeles and the other towards the new skyline of the Arts District, which is going to have basically an entire new skyline by Herzog de Meuron, Bjarke Ingels, David Adjaye. Looking at this kind of three forms that were pivoting around the central vortex of the event space, all of the functions that are here, but wanting to embed it with a series of values. And the client assigned it a name, which was Uxmal. Uxmal is the name of an ancient Mayan capital, which means thrice built. And it's thrice built because this particular site is our building that's being built over the existing building, and then our new building being built inside of that one, so the three times. But what we were really fascinated by was we began looking at some of the patterns of the original Uxmal, which you see here. Some of the geometrical ornaments, masks, and figures, and realizing that they were actually universal patterns, like they were existing in ancient Mayan culture, but also in ancient Greek, in ancient Chinese, and ancient African, Adrinkan cultures. And really beginning to think about how values could be expressed literally as patterns, and in this case beginning to aggregate what were Mayan symbols, Chinese symbols, Adrinkan, African symbols, Greek symbols, and symbols that actually had meaning, and beginning to filter these as symbols about equality, symbols about power, symbols about energy, symbols about spiritualities, symbols about future forward thinking, and mapping these and beginning to assign kind of literal value to them. And then looking at them computationally as ways of indexing what's actually happening in the geometry. And looking at a process that's known as recursive subdivision, which in this case is an analysis of curvature, and then incrementally subdividing more and more and more based off of the amount of curvature that's in the surface. So as you can see here, where it gets more curved, it gets subdivided more. So you have, basically it's like resolution, pixels, right? Like you need more pixels when you need something more articulate. You need fewer pixels when you need things that are bigger. And then that became a way for us to map these symbols onto the surface and have an indexing, which not only equated to a visual variation, it literally became a way of mapping the constructability of the project. So this is one that we worked very closely with Zahner, a manufacturer in St. Louis. Kansas City, that's right. Basically, if you see here, the project is a kind of a world inside of a world, right? There's the building itself, and then there's this intermediate area where you step into the space between the actual building and our building inside of a building. And then there's a third world, which once you step into the gallery space, there's a series of vaulted volumes and display space and event space that is very, very unique and has a series of kind of what we call soft subdivisions, where we use the section to carve out different gallery spaces rather than walls. And I forgot, there is one project more, which only has one thing, which is just a video. And I'll show this one very quickly before I go on. And so this idea of the kind of cultural values and the mapping of historical architecture and the connection to things that are, let's say, in this case, ancient, like the pyramids of Egypt, and mapping them towards something that's hyper-contemporary. We got commissioned to do a hotel in Cairo, which is adjacent to the pyramids, about 2-minute drive away, right next door to the Grand Pyramids of the Grand Egyptian Museum by Hennigan Payne. And we looked at those kind of horizontal layers and the kind of stereotomic geometries of the pyramids as a departure point to begin thinking about this kind of subtractive process and additive process of multiple layers and how that gets articulated as a kind of geometry that could actually be read in a very, very contemporary way that isn't doing the things that, like, say, the Luxor does in Las Vegas, which kind of mimics the pyramids, even the pyramids I've seen out here. There's like this series of 3 pyramids between Indianapolis and here, where you're quite literally kind of mapping the pyramids, but I'm kind of thinking of the pyramids as a departure point for how we think about a more contemporary view of architecture. So I'm going to end with this slide because I always end with this slide. And this is a quote from Mark Weisler. For those of you who are not familiar with him, he's known as the godfather of ubiquitous computing. And basically, what he's saying is that technologies are most profound when they disappear. Right? When you don't think of them as technology anymore, like they just are. Right? And I've been talking about this repeatedly over and over and over again, in part because the first talk I ever gave was in 2009 at an event called Digital Architecture. So I thought I was going to be hot shit and come up at digital architecture and talk about digital architecture and strike out the digital. And it's just stuck with me. And I think the image here is what at that time was known as a horseless carriage. Right? And so it was what we now know as the car. But now nobody cares about the car anymore. Right? And this is something that we're going through right now with a lot of technologies that we're going through, including digital technologies, right? And all it takes is one generation, and nobody cares about the previous version of it, right? We're currently starting to talk about driverless cars. In one generation, they're not driverless cars anymore. They're something totally different. Like nobody cares that there was a driver. So we have an opportunity to think about them very differently. And I think that's the same when I approach architecture. Thank you.